Okay, this is the last problem that we're going to be looking at as far as pyramids go. So if you've been following, if you've been doing the other videos that are with three-dimensional shapes, I always put one like this, where there's two shapes that have the same volumes. So the pyramids have the same volume, but obviously they have different shapes or different dimensions, right? So the question would be, what is the width of that second pyramid? How do we find that? And I decided to look for width because we did one where we had to find the height. So I thought I'd change it up a little bit, and this time we'll look for width so we can see how that looks like. But I already said it's just like that one problem that we did looking for height, right? But this problem has another step more, as do all the ones that have the two shapes that have equal volumes and you're missing one dimension, and that's what you're asked to look for, right? To find. So where do we start? Actually, since if you have done these other videos, why don't you stop the video and see if you can answer this one, okay? So go ahead and stop it. Give it a go. You need algebra. Give it a go. All right, so what'd you get? Did you get it right? All right. Your clue is that it's going to be a nice little pretty number, right? Not no decimal. Not no decimal. My double negative. Okay, sorry. Okay, so let's see here. What do we do first? All right, what do we do first? They say the volumes are the same, but do I have the volume of either or, of one of the two pyramids? I don't. Now, the next question would be, can I find the volume of one of these two pyramids? Because if I can find the volume of one of them, I automatically have the volume of the other one, because they tell me that the volumes are the same. So, I do have enough information in this pyramid to find the volume, and in turn I'll have the volume for that one. Once I have the volume for that one, then I use algebra to reverse engineer the volume, basically, to find that width. And we'll see how it goes. All right, so let's see. First things first, I have to find the volume of the pyramid that has more information, and that's going to be this one. So, using our formula, length and width in this one are the same, right? It's the same. They're 5 times 5, so let's just put 5 times 5 times 6 times the height, right? Divided by 3. So this one, there's really nothing to it. It's just a matter of doing those two multiplications, the division, and then bam, we're done, right? So just to make things a little bit quicker for us, I'm going to go ahead and use a calculator. So, I don't know, maybe you guys can see it. Hopefully you can. 5 times 5 times 6, right? I could just put divided by, but I'm not going to. I'm going to say equals 150. 5 times divided by, what was it? 3. That constant 3. So 50. That pyramid has a volume, or I guess both pyramids have a volume of 50, in this case, centimeters cubed. They both have the volume of 50 centimeters cubed. Okay? So, I might as well put something like that so we can see it. Volume 50 centimeters cubed, and then this one has a volume of, oh, you guys can't see that far, huh? I can do it sideways. I will not be defeated. I can just put it down here. Volume is equal to 50 centimeters cubed. Okay, and that's for this one, and this is for that one. So they have the same volume. And I have to do that because I'm going to have to erase this, okay? But quick, just to repeat, we just followed the formula, and we used the pyramid that had all the information to find the volume using the formula, and we did it. Boom, 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 and boom, divided by 3, and we're done, okay? All right. So now that's an important thing. Now that we know the volume of the pyramids, that's all the use that this pyramid's going to give me. I don't need this pyramid for anything else anymore, because the problem is really referencing this pyramid over here, where they give me, I guess we can call that one length, right? They say the length is 5, the height is 10, but we're missing the width. And we have the volume, right? We have that volume now. So let's go ahead and start with that one. And like I said, I'm going a little bit quicker this time because we've seen these kind of problems, hopefully, right? And at this point, now that we have the volume, you know, so length times width times height divided by 3 gives us 50. This is just like that second problem that we did. So let's just keep moving. This case, they gave us the length. They gave us 5. Times width, we don't know. I'm going to go ahead and make it a lowercase w. Times height, we have the height, 10. Divided by 3 is equal to 50. Okay? And we know that when there's only one variable missing, we can solve for that. We can do the algebra will work, is what I'm trying to say. Algebra will work to find the value of that width. Now, when we did the pyramid that was just missing the height, we had the length and the width, and we multiplied those together. I can do the same thing here. Just because they're not next to each other, the two numbers that we have, the 5 and the 10, it doesn't mean that I can't multiply them. Remember that multiplication, it doesn't really matter the order in which you multiply. And that's why I sometimes get these two confused. Sometimes I put length times height times width, or length times width times height. It's the same thing. Because when we're multiplying, it doesn't matter which order you do it in. 2 times 5 is the same thing as 5 times 2. So I can basically go ahead and do this multiplication, 5 times 10, and that gives me 50, right? So now I have 50w, 50 times w, and this is where I start writing it more in the algebraic form, just writing the letter or the variable and the number right next to each other to signify multiplication, divided by 3 is equal to 50. All right, now this is where we have to get rid of that fraction. Remember that when we're doing the algebra, solving equations with fractions, we want to eliminate the fraction, and the only part of the fraction that we can ever change really is the denominator, the bottom number. So we're going to do this one exactly the same way we did the last one, because it's the same number. That 3 never changes. So to get rid of that divided by 3, I'm going to multiply by 3. Remember that my 3 that I'm multiplying by has to be in fraction form because I have fractions in the problem. Now, these two will cancel out, cross-canceling, right? A numerator and the denominator that can be divided by the same factor, and they can both be divided by themselves by 3, leaving 1 behind. 3 divided by 3 is 1, 3 divided by 3 is 1. And then just to go ahead and do the process, 1 times 50, w is 50w. 1 times 1 is 1, but just the same way that 3 divided by 1 is actually 3, or 3 over 1 is 3, 50w over 1 is just 50w. Whatever number divided by 1 is that number. That's what we're basically saying. But remember, what I did to this side, I have to do to the other side. I multiplied this side times 3, so I'll do the same thing over here, times 3. 50 times 3 is 150. 150, yep. Okay, and the last step is to separate the 50 from the w. Now we know that the 50 and the w are multiplied because that's what the formula says. Everything in that numerator is multiplied, so these are still multiplied. And to separate them, I have to undo that operation, which is division. To undo it, I have to do the opposite, right? So the opposite of multiplication is division. And what I do to one side, I always got to do to the other. I have to maintain balance in my equation. So 50 divided by 50 is 1. 1w is just 1w. I'm not going to write the 1 or 1 times w. I know that 1 times w is w. And 150 divided by 50 is 3. Okay? So, or I guess we put the units, 3 centimeters. And I guess I could come over here, right, and say that one's 3 centimeters. Not the prettiest handwriting. I know. But, okay. So that's how we do it. This is a very similar problem that we've seen in both pyramids and all these three-dimensional volumes examples that I do. I always try to finish off with one of these ones where they compare two things. They give us some information, it's kind of hidden, and we have to kind of start looking at the steps that we need to solve for that one small piece of information they were asking for. Okay? So there we go. So just keep working with these problems. Get good with your algebra. Your algebra foo has to be strong. And so go over all these other shapes that I cover. The cylinders, the pyramids, the cones, the triangular prisms. And if you watch them over and over, not to say that you need to watch them a lot, but if you do, that's fine. you'll start seeing the patterns in these problems. And it's not to say that these are the only kinds of problems that exist in relation to volume, but they're very common, and the idea of doing different kinds of problems, even though I don't do every single one that ever existed, the idea is that you start seeing the differences and the similarities, and you can start seeing those connections about what are the important skills that we need to know to really be able to take those tools into any problem and really take them apart and put them back together, whatever they're asking us to do. All right, so good luck, keep practicing. Here we go.